Hey guys, welcome back. In this video, I'm just going to discuss 4 types of graphs for polynomial functions. Remember, polynomial functions are functions that are continuous, so they don't have any breaks or jumps or asymptotes or any of that stuff, okay? What I really want to just talk about is what happens at the end. If you think about it, there's 4 different options. A polynomial function can, do some crazy things here, but at the very end, they can both go up. Here, in this example, I'm just going to do this. They can both go down. I'm going to talk about what I mean by they can both go. Here, they can one go down, one go up, and then obviously the next part would be where one is up and one is down. These are the directions of the end, or what happens at, let me put that here, negative infinity and positive infinity. Negative infinity and positive infinity. Negative infinity, positive infinity, and negative infinity and positive infinity. So these are basically the 4 end behaviors for any polynomial function. If the arrows are pointing in the same direction, that means that the function has an even degree. So in this case here, this function here and this function here, the arrows at the very end are pointing in the same direction. They're both either going up or they're both going down. That means there's an even degree. Now you might say, what do you mean by an even degree? Well, that means the highest exponent in the polynomial function is an even number. It can be x to the 8th, x to the 10th, x to the 14th, and so on. If they are pointing in the opposite direction, that means the function has an odd degree. So if one is down and one is up, or one is up and one is down, that means that the highest exponent is odd. It doesn't mean that it's an odd function. It doesn't mean that it's an even function, because even functions are symmetrical with respect to the y, and odd functions are symmetrical with the origin. It just means that it has an even degree as its highest exponent or an odd degree as its highest exponent. So you might ask yourself, how do we know if it's both going up or down, or if they're opposite? Well, it's very simple. First thing that we're going to do is we're going to locate the highest degree. And in this case, I wrote it in a way that the highest degree doesn't start. This is it. And you take the negative 4 with the x to the 7th. So we're going to take its coefficient. And we're basically just going to look at this part here. So let me move this a little bit down. So here, what happens as x approaches infinity and negative infinity? What happens to the y? Okay. What I want you to do is don't worry about infinity. I just want you to worry about the positive sign. What would happen if you put negative 4 times a positive number to the 7th power? Isn't it true that a positive to the 7th power is positive? Right? Positive, 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 positive. So that number times the negative from the 4 will give you a negative. So therefore, when you plug in a positive, you get a negative as your outcome, okay? What happens if you plug in the negative? So if you plug it into the negative 4x to the 7th, if you plug the negative in, negative to the 7th is negative, times a negative from the 4 becomes a positive. So what does this mean? This means that on the right side of the graph, it goes down. On the left side of the graph, it goes up. So we're looking at the right side of the graph, it goes down. The left side of the graph, it goes up. So your picture will be something like this at the end. Let's try another one. So you can pause the video if you need. Okay, I'm just going to erase this because I need some room. Here's our next problem. Take the highest exponent and the number in front of it. So what happens as x approaches infinity. So I'm going to just write 2x to the fourth here. I'm going to just put a positive in there. Positive to the fourth power is positive. Positive times the positive becomes positive. What happens when you put a negative into this? Negative to the fourth power is positive times the positive gives you positive. That means this type of graph, we don't know what happens in the middle, but at the very end, the end, on both sides, it's going to be going up. So that's this graph right here. So that means that's that graph, okay? In this case here, my highest is this. So I'm only going to look at this. What happens as x approaches infinity and what happens as x approaches negative infinity? Well, when you put a positive here, what's a positive to the 9th power? Positive times the negative from the 3. Positive times a negative is negative. So the y approaches negative infinity. And what happens when we put a negative in here? Negative to the 9th is negative, right? Negative times 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 negative. That's negative. Times the negative 3 is positive. So what does that mean? That means on the right side, I'm going to go down. On the left side, I'm going to go up. So it might look something like this. And our final problem is this right here. So, same thing, as x approaches positive infinity, y will approach positive infinity, and as x approaches negative infinity, y will approach negative infinity. Because if you put a positive to the 7th, it's positive, okay, and so on. So that's pretty much how we are going to do end behavior. If we're going to do these last problems, what is the end behavior of the function? All I care about is the highest exponent with the number. So I'm only looking at negative 4x to the 3rd. As x, watch this problem, it starts at the left side. When x approaches negative, put a negative. Negative to the 3rd is negative, times the negative from the 4. That's positive. So it's either going to be this or this. And then as x approaches infinity, positive to the 3rd is positive times the negative is negative. So therefore, everybody should be choosing choice 3, okay? We'll do one more. Pick the highest. It's going to be that. And now I just want you to think about it. Even numbers point in the same direction. So it's either this way or this way. Because it's positive 7, it'll be this way because they're both going to be pointing up, which means on both ends, the left and the right, you're approaching positive infinity. So that's why I did that in the beginning, just to say that you don't really even need to figure out algebraically. You can just say, oh, I know this opens up for both of them. So that's that. Okay? Have a great day.